Alright, so in this video I'm going to be talking through pages 13, 14, and 15 in the notes packets, all about transformations. We already did the kind of most straightforward types of transformations that include reflecting it across the y-axis or reflecting across the x-axis by making the function negative, translating it up by adding or subtracting an amount at the outside of the parentheses, and moving it left and right by adding or subtracting inside the parentheses. Now we're going to talk about stretching the function up or compressing it. And we do that by multiplying something in front of the function by some number. And if the absolute value of that number is greater than 1, then we are stretching it. If that number is smaller than 1, then we are compressing it. And obviously if it's negative, then you're flipping it below the x-axis, whereas if it's positive, it stays the way it is. So let's start with our parent function. That's going to be a parabola. Looks like this. And if we multiply it by 1/2, then each of these points, the y value, we're going to cut it in half. So if we start with 1 over in our normal parabola, we have 1, 1. Here we have 1, 1/2. What used to be 2, 4 is now going to become 2, 2. And we can also go another point here because we would take 3. 3 squared would be 9. Split 9 in half, and we would get 9/2, which would go there. And because it's a parabola, it's going to be symmetric on this side. And so what we've basically done is we've taken our parent function and we've squashed it down so that it is less steep. If we multiply it by 2, we're going to have the opposite effect. We're going to make it more steep. So what used to be 1, 1 is now going to become 2, 1, and its pair is going to go there. And what used to be 2, 2 is now 2, 8, so we're already off the graph. So we multiply it by 2, that makes it even steeper. All right, so we have some practice down here. So once again, starting with our original parent function, y equals x squared. We have y equals 3x squared minus 4. So we're going to start with a vertical translation. So vertical translation down 4. I'm going to just write translated down 4 units. And then we also have a vertical stretch by a factor of 4, and that comes from the 3. So this minus 4 here tells us that we're taking our function, we're sliding it down 4. And then this tells us that we're making it steeper. So we would go over 1, up 1 in our normal parabola, right? Over 1, up 1. But now we're going to go over 1, up 3. And we would normally go over 2, up 4 in our parabola. But instead we need to go over 2, up 8. That's going to bring us to positive 4. Meaning that our parabola is going to look something like that. All right, and then for this one, we have 3 different translations going on. We're going to reflect over the x-axis. That comes from this negative number out in front. We're going to vertically compress by a scale factor of 1/2. And then over here, we're going to translate 1 unit to the right, or to the left. Sorry, because we're adding, so it's translated to the left. So that means our original function would start at 0, 0. We're going to go 1 unit to the left. That's our new vertex. And then we're going to now go down, but we're going to do so with half the steepness of the parent function. So it's going to look something along the lines of that. All right, and then on page 14, we're talking about something that might be a little tricky, and that is horizontal compression. So this is where instead of multiplying outside of the parentheses, we multiply inside of parentheses. And the interpretation there is we're kind of taking horizontal space and we're making it happen twice as fast. So now when you go from 0 to 1, it's actually like going 0 to 2. So what that means is in our parent function, right, we have 1, 1, or we have 0, 0, 1, 1, 2, 4. Right, those are our first 3 points. And we know that if we stretch that by a factor of 4, then suddenly 1, 1 becomes 1, 4, because we need to multiply the y value by 4. But if we think about that as a horizontal compression by a factor of 2, then when we go to 1, we multiply that by 2 to get 2, and then we square it to get 4. So the reason why horizontal compressions can be a little tricky is because they can achieve a similar result as a vertical stretch, depending on what the function is, and depending on how it looks. So here, what this is actually doing is it's taking this function and it's squeezing it inwards. So that looks like this, which is the same as stretching it upwards. So slightly different mechanism, but you can get to the same result. And the same thing goes the other way. And the reason why you see a 2 here versus a 4 here is because this is happening before the square. So this 2 gets squared and it becomes 4. That's why these two graphs look the same, even though they have different functions. And the same thing happens with horizontal stretches. So the other thing to note is that when you multiply the inside by a bigger number, we're compressing. When you multiply by a smaller number, we're stretching it out. So here, we still have our parent function. Goes like this. If we compress that downwards by a scale factor of 4, we're going to have 1, 1/4. We're going to have 2, 1. And we're going to have 3 and 9/4. You go there and there. 4 would normally be 16, but if we divide that by 4, it's then going to be 4. 5 would normally be 25. 25/4 is finally off the graph. So it's going to look something like this. And if we think about horizontally stretching it by a factor of 1/2, when we plug in 1, well, that gets multiplied by the 1/2 inside, and therefore becomes 1/2, and then when we square it, we get 1/4. Same with when you plug in 2 here, that becomes 1. So 2 is going to map to 1. 3, that's going to become 3/2, and it's going to get mapped to 9/4. 4 is going to get mapped to 2 squared, which is also going to be 4. And then we're off the map. So you can see that whether we think about it as a vertical compression by a scale factor of 1/4 or a horizontal stretch by a scale factor of 1/2, we get the same function either way. All right, and the other thing that we can do, this should not say horizontal stretch, this should say horizontal reflection. The other thing that we can do is when we put a negative outside of the parenthesis, we know that flips the function from being up to being down. Well, when you put a negative inside the parenthesis, what that does is it flips everything from the right side of the graph over to the left side. It's a horizontal reflection. So that's clear for a function like 2 to the x. So if we think about what that's going to look like, it's an exponential curve, so it goes off like this. If we make it negative, well, then all of those values become negative. And it looks something like that. But if we make it negative on the inside, then if we plug in 1, it becomes negative 1, leading to 1/2. If we plug in 2, it becomes negative 2, leading to 1/4. But if we plug in negative 1, then it becomes positive 1, leading to 2. And as a result, we've taken everything from the right side of the graph, right, what used to be on the left side of the graph, and we flipped it over to the right side of the graph. And everything that used to be on the left side of the graph, we flipped it over, and it's now on the left side of the graph. And then finally, we have page 15. This is where we're talking about circles. And so circles are kind of distinct in that they have their own formula. And that's x minus h squared plus y minus k squared equals r squared, where h and k give us the center of the circle, and r gives us the radius of the circle. So for example, if we have a graph that is centered at -1, 2, that means its center is going to be there. And it's going to have a radius of 3 units, which means it's going to have points that are 3 away in all directions. I'll do my best to connect those into a circle, like that. Its function is going to take the form, so it's going to be x minus h, where h here is the x coordinate of the vertex, so it's -1, h, so x minus -1 is going to be +1. This is kind of backwards, just like, because it's in parentheses, when you need to add to go backwards, subtract to go to the right, plus y minus 2 squared, and all of that is going to equal our radius squared, which is 9. If we go down here, we want to graph the circle. So where's the center of the circle? Well, the center of the circle is at 2, -1, because it's backwards, right? So if you subtract 2, you go 2 to the right. And we have a radius of 4, meaning that our points are there, 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 and there. And then you just connect them all, like that. And write the equation for this circle. So we see that we have a center at -2, 6, meaning that it is x plus 2 squared plus y minus 6 squared. And our radius is 5, meaning that what we should put over here, which is our radius squared, is 25. So there's the equation for that circle.